Hello, everyone. Last day. Let's get her done. And then let's take a nice spring break. Unit 6, Lesson 4, Reasoning about Equations and Tape Diagrams, Part 1. So you're going to have a long time to have to wait. I know you're going to be so anxious to hear about what Part 2 is, but you're going to have to wait all of spring break. As for Part 1, it says, let's see how tape diagrams help us answer questions about unknown amounts and stories. So we've kind of already done that, but let's improve upon it because this is setting the foundation for a huge chunk of 8th grade. That being said, let's rock. Algebra talk, seeing structure. Find a solution to each equation without writing anything down. Number 1 is kind of saying, hey, what plus 1 is 5? You guessed it. Number 2, it's like saying 2. Let's use some magenta today. 2 times what is 10? Well, I know 2 times 5 is 10. So I have to think to myself, well, what plus 1 is equal to 5? Well, that must mean that's 4. 2 times 4 plus 1. 4 plus 1 is 5. So a lot going on there. But if I would have plugged that in, therefore x is equal to 4. Number 3, same type of problem. 3 times what is 15? Well, 3 times 5, well, guess what? In this case, x is going to be 4 again. And the last one is kind of saying 100 times what is equal to 500? Well, I know that must all equal x plus 1 must equal 5. And lo and behold, they tricked us. X was equal to 4 for each one of those. Darn them. Oh, and it said without writing anything down. Oh, well, I wrote something down. Darn it. Oh, well. Ignore you saw anything. Just ignore that. 4.2, situations and diagrams. Draw a tape diagram to represent each situation. For some of the situations, you need to decide what to represent with the variable. Number 1. Diego has 7 packs of markers. Each pack has X markers in it. After Lynn gives him 9 more markers, he has a total of 30 markers. Do you think you could write this tape diagram? Have at it. I'll draw one for you. That was nice of me. See what you can do. And then let's see. Go ahead and hit pause if you want, and then unpause it. And you can see how you did. Yeah, I know most of you didn't pause it. Oh well. 7 packs of markers. Each has markers in it. So that means there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And a 7th pack. 7 packs has X markers in it. We don't know how many they all have. Then there's 9 more markers. All together, he's got 30. Beauty of this, doesn't even say to solve. Thank you very little. Here we go. Elena is cutting a 30-foot piece of ribbon for a craft project. She cuts off 7 feet and then cuts off the remaining piece into 9 equal lengths of X feet each. 30 feet piece of ribbon for a craft. She cuts off 7 feet, and then the remaining is into 9 equal pieces. So, make sure you make those sound effects. So what are we going to do there? Well, 9 equal lengths. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 equal lengths of X. And she cuts off 7. And all of that is equal to 30. take a look at that and see if that makes sense to you. Pause it if you have to, but that's what that's essentially saying. There's my ribbon, 9 equal pieces, and then there's one that's just 7. That might not be drawn to scale, but that's all right. I'm just drawing random links. All right, number 3. A construction manager weighs a bundle of 9 identical bricks and a 7-pound concrete block. The bundle weighs 30 pounds. Here's our tape diagram. 9 identical bricks. 1, 2, 3, 4, 5, 6, 7, 8, 9. We could choose anything. We can choose B if we want. Bricks, 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 bricks. Is that 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And a 7-pound concrete. This bundle altogether weighs 30 pounds. That looks awfully familiar to that first one. Except I use B and X. Doesn't matter, but go figure. Number 4, a skating rink charges a group rate of $9 plus a fee to rent each pair of skates. A family rents 7 pairs of skates and pays a total of $30. A skating rink charges a group rate of $9. So no matter what, your entire group got to pay $9. Then everyone's got to rent their own skates. But if you have a group, it's $9. Group of 5, group of 10, doesn't matter. $9, I guess. That's not real specific, but either way, it's a $9 group rate. Plus a fee to rent each pair of skates. A family rents 7 pairs of skates. So we don't know how much skates cost. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All those X's are the cost of a skate. Plus the $9 for the group. All of that's going to equal 30. And then finally, this one's a tricky one. Andre bakes 9 pans of brownies. He donates 7 pans to the school bake sale and keeps the rest to divide equally among his 30 classmates. There's a long way to do this and a short way. I think I'm going to do this the short way. 30 students. We essentially got to divide all of this among 30 students. So I'm going to take the shortcut way. We're going to call that 30x. I could draw 30 x's. That would be like this. 1, 2, 3, 4, 5, 6, 7. But I'm not going to. We're just going to write 30x, and that stands for 30 x's. Got it? So there's 30 x's. Right? And then there's also seven pans. And then this is kind of weird. That's 9. So we got 7 pans. The whole thing is 9 pans. 30 students and 7 pans is going to be a total of 9 pans. That'll make more sense when we actually try to solve this. But there they all are. That one was a tricky one. Number 4.3 is going to use all of those pictures we just drew and translate those to an equation. So if you notice, it says each situation in the previous activity is represented by one of these equations. Match each situation to an equation. So, number one, Diego has 7 packs of markers. Each pack has X markers in it. This looks like there are 7 X's and a 9 equaling to 30. You're going to notice number 1 goes with that one. There's 7X. 7 times however many are in each marker plus the 9 markers equals 30. So let's look at number 2. There's 9 X's and a 7 equaling to 30. Well, there's 9X and a 7 equaling to 30. So that must be number 2. Number 3, there are 9 B's, or 9 X's if we really wanted to call it X. I just chose bricks. And 7 again. So guess what? It looks like number 3 goes with that one. Number 4, there are 7 X's and a 9 equal to 30. And that's just like that one. And number 5, we see 30 X's and a 7 equal to 9. So that one goes with 5. So we've matched each one. Now we need to find a solution. We need to figure out what X equals. So for the first one, we're going to notice if we get rid of this 9 first, right? If there's 30 markers, if we get rid of the 9, we're left with 21. That 21, I should probably switch colors because let's use green. Yeah, what the heck? That's going to be 21. And then there's 7 packs of markers. That 21 we need to split 7 ways. That means there's going to be 3 markers in a pack. Because we're now answering the next question. The final question says, interpret your answer. X equals 3. Well, what does that even mean? Well, that means there's 3 markers in each pack. So we've answered the question and then we're interpreting it. Number 2, there's a 30-piece ribbon. She cuts off 7. So we're going to take that 30 and get rid of that 7, which is going to leave 23. This is weird. Cuts off 7. Am I doing my math right? Yeah. And then the 9 remaining pieces are going to be, the 23 feet that's left are going to be split 9 ways. So I got to take that 23 and split it 9 ways. And that's kind of weird that they gave us that problem. But so be it. That means 9 goes into 23. 3 times would be 27. So it's going to be 2 times with a remainder of 5. Because 2 times that is 18. 18 plus what is 23? So it's going to be 2 5/9. That's going to be equal to X. So what does that mean? That's each length of ribbon. The remaining 9 pieces were cut up, so there it is. Number 3. A construction manager weighs a bundle of 9 bricks and a 7-pound concrete. Well, we've already solved this one. It's the same as above. We know that it is 2 5/9. But this times it is pounds. In other words, each brick, 2 5/9 pounds, is the weight of each brick. And then there's a 7-pound, 9 of those. Did I do that right? Yeah, divide by 9. Yeah, same problem. And believe it or not, we've actually already answered number 1. We already know the answer is 3 because we get rid of 9, then we split it 7 ways. But what does the 3 mean? We know that X equals 3. Well, in this case, it says a family rents 7 pairs of skates. So 3, and we should give it a dollar sign because $3 is the cost for one rental. And we could say one rental of skates. And then finally, Andre bakes 9 pounds. He donates 7 of them. So out of 9, he donates 7 of them, which means he's left with 2 pans to share among 30 students. So if this was X's, we could go 1, 2, 3, 4, 5, 6, 7, 30. And we're going to split that 2, right? We're going to take off 7 from 9, which means the rest, we're going to say this is 2 pans. It's getting split among 30 kids. So how much does each kid get? 2 divided by 30 is equal to 2/30. We could leave it like that or simplify it to 1/15. Both the numerator and the denominator can be divided by 2. Each kid gets 2/30 or 1/15. What does that even mean? X equals 1/15. That's what everyone gets, 1/15 of a pan of brownies. And we should probably write that. Each student gets 1/5 of a pan of brownie. 1/15. And boom. We're done with 4.1, 4.2. We did say, what does each solution tell? And we're done. There's some great scenarios right here in the summary. If you are wanting, those 3 are great. They all use 1034 and 144, but they're all great examples if you need or want to look at some more examples of how I guess, what you didn't note, what it's doing is giving you more examples. You just solved those equations, and you solved that equation, and you solved that equation. The first thing we did with this one was, hey, we got rid of 9. We got rid of 9 from 30. And then we split it 7 ways, dividing it by 7. First thing we did with this one is we got rid of 7 from 30. And then we split it 9 ways. When I say divide by 9, that means split 9 ways or divide by 9. And then the same thing we did here for this one. We got rid of 7 pans and then split that 30 ways. All right, let's take a look at your homework. Lesson 4, practice problems. Draw a square with a side length of 7. Now, if we had a ruler, great, but for now, we can pretend that's a square. Actually, 7. Let's go ahead and try to draw it to scale. Who knows? Let's call that 7. So there's a square. The side length is 7. Predict the perimeter and the length of the diagonal of the square. Well, we can predict the perimeter with the exact amount because that's just saying 7 times 4. The perimeter is 28. P equals 28. Perimeter is the distance around. Now the diagonal, it's saying, what's the distance from here to there? What do you think that's going to be? Well, I can tell you this. It's got to be more than 7. Can't be much more than 7. If I drag this diameter down, I'd run out of room, but it's essentially going to be longer. Let's do it this way. If this is my diameter or diagonal, if I dragged it down here, you could see it's going to be more than 7, right? If I just dragged it down, that line would be more than 7. Let's call it green. No, I said green. Here's my green line. If I dragged it down, it would be about like that, right? So my answer is going to be more than 7. So my guess is, let's call it 8. Now it says measure the perimeter and the length of the diagonal. Oh, that was my prediction. I should have said the diagonal equals 8 on my prediction. Or we could say 9 or whatever we want. Now, in eighth grade, you're actually going to learn how to calculate that. There is a formula for that. It's called the Pythagorean theorem that you can find that. For now, if we measured it and everything was drawn exactly to scale, I believe the exact answer would be 9.8. Describe how close our predictions were. Well, we would say we were 1.8 off, if that was our guess. And it's a little bit more exact than 9.8. It's a very long decimal, but let's call it good for that one. Number 2 says find the products. Well, I'll let you guys do that. You can use a calculator except if you use a calculator, you kind of defeat the purpose. It wants to know, can you do this with, well, actually, I mean, we pretty much can do all of this. 100 times 0.09, guys, that means move the decimal 2 places to the right, and it's going to be negative. So there's my answer. 7 times 1.1, that's like 7 times 11, which is 77, but it's not 11. It's 1 decimal place value less. So I'm going to move this back. So my answer is 7.7, and my answer is positive because guess what? A negative times a negative is a positive. Letter C, don't know what the answer is, but I know it's going to be negative. Letter D, don't know what the answer is, but I know it's going to be positive. But I'm not going to lie, I actually do know the answer to letter D, because this is kind of like saying, what's 2 times 3? It's 6. Well, what's 0.2 times 3? That would be 0.6. Well, what's 0.2 times 0.3? There's 2 decimal places, so actually I can go 1 back, 2 back, which suggests that my answer is actually a positive 0.06. And for C, I'll let you do that. You can do that quickly on paper. What's 73 times 5? And then you can move the answer back a decimal place because it's not 73, it's 7.3 times 5. So I know my answer's got to be somewhere around 35 because that's like saying 75. It's going to be slightly more than that. 7 times 5. Number 3. Here are 3 stories. A family buys 6 tickets to a show. They also pay a $3 parking fee. They spend $27 to see the show. Decide which equation represents each story. What does X represent in each equation? Find the solution to each equation. Show your reasoning. And what does the solution tell you about its situation? Well, that's kind of like, this question is kind of like saying that is. So if a family buys 6 tickets to a show, don't know how much a ticket is, it's kind of like saying, well, 6 times what plus the $3 is the total of the $27 they spent. Guess what? That's exactly that one. So if they spent a total of $27, and let me write it over here. If we get rid of that $3, that leaves 6 tickets for their parking fee. That leaves $24 left for the 6 tickets. Well, if we split that 6 ways, guess what? X equals 4. It says, what does X represent? I should have said, if we're going to do this correctly, we need to draw an arrow. That's the cost of a ticket. So that's what X represents. Letter C says, what does each solution tell you about its situation? Well, guess what? We can circle that. X equals 4. Well, $4 is the cost of a ticket. So A and C kind of are the exact same thing. So Diego has 27 ounces of juice. He pours equal amounts for each of his 3 friends and 6 ounces for himself. So 27 ounces of juice. 3 of his friends get who knows how much. He gets 6 ounces, And altogether, that's 27. Which one does that look like? Well, that's that first equation. How would or what does x mean? Let's go ahead and write that. That's the equal amounts for each of his three friends. That's how many ounces a friend gets. Maybe that's what we should write. I'll let you write that. That's how much a friend gets. That's how many ounces a friend gets. And then, how do we solve that? Well, let's get rid of, when you learn this in 8th grade, you're going to know, you're going to learn it this year. You're going to want to when you're solving this, you're getting rid of it from each side of the equal sign. We'll explain more why that is later. But if you haven't noticed already, that's what I'm already in the habit of doing. So if we get rid of the 6 ounces that he drinks from the 27 ounces, that leaves 21 ounces to share among his three friends. So we're going to split that 3 ways, and we'll get 7. So what's that? 7? That's the amount that his friends get. And then finally, Jada works for 6 hours preparing for the art fair. She spends 3 hours on a sculpture and then paints 27 picture frames. Let's read that one again. Jada works for 6 hours preparing for the art fair. I'm guessing we already used this one. Guessing it's that one, but it could maybe be one of the others. Maybe that's a decoy. Maybe we'll use the same one again. Jada works for 6 hours preparing for the art fair. 3 hours were on a sculpture. And it doesn't say that, but maybe it should say in the remaining time. And the rest was meant for painting 27 picture frames. So that's where I'll write it up here. So first off, what does X stand for? I would write it. Oh, that's fine. So it is 27. Let's just draw a little box for us to work in. 27 times whoever knows how long that she's working per picture frame, plus the 3 hours. 27 times, that's the time. This is the time per picture frame. That X is the time per picture frame. So 27 times however long she took for a picture frame, plus the 3 hours, is going to equal the total of 6 hours that she was preparing. She worked for 6 hours. 3 of it was for the sculpture. So if we get rid of the 3, that means 27 picture frames times how much is going to equal the rest of the 3 hours. Well, guess what? If I split that 3 hours among 27 picture frames, that means there's 2 ways you can do this. One, just leave it like that. Guess what? X equals 327. So that's hours. And we could simplify that. I'll write it over here. That's also equal, both 3 and 27 go into, both 3 goes into both 3 and 27. So that's equal to 1/9 of an hour. That's the amount of time. If it says, what does each solution tell you about a situation? That's the amount of time worked on each picture frame. A 1/9 of an hour. So I'd have to take 60 minutes and divide it by 9 to really figure out how many minutes. And 60 divided by 9 would be somewhere between 5 and 6 minutes. And we're almost done. Number 4, here's a diagram, and it's corresponding equation. Find the solution to the equation and explain your reasoning. So they even gave us the equation that 6x's and an 11 equals 21. So first thing, let's get rid of the 11. Let's subtract 11. That means we've got 6x's. We got rid of 11, then that means these 6x's are going to be equal to 10. And then we need to take that 10 and split it 6 ways. You could say 10 divided by 6. Or that's the same as saying 10 divided by 6. And guess what? X equals 10/6, which is also equal to 1 and 4/6. Both of those are correct. And we could say that's 1 2/3 if we really wanted to. But it didn't even say to simplify. And we explained our reasoning. And then finally, plot these points on the coordinate plane. If you remember, the first number tells you how far left or right you go, and the second number tells you how far up or down you go. So when it says 3, 2, it means I go right 3, up 2. There's A. 7.5. 7.5 up 2. There's B. C is 7.5 down 2.5. There's 3, so that must be C. And D is over 3, 3 and down 2. Right there. What's the vertical distance between D and A? Whoops. So what is the distance? Wish you would just switch colors when I tap it. What is that distance? Well, 1, 2, 3, 4. It says write an expression that represents the vertical distance between B and C. It's kind of like saying here's B. The vertical distance is 2. And to find the difference means subtracting, and C is a negative 2.5. We'll call it X. That's the distance. So that's an expression. It doesn't say to solve it. But what the heck? 2 minus a negative means 2 plus 2.5. And guess what? That's 4.5. And if you look at the distance right there, it's 1, 2, 3, 4.5. And we actually did the same thing with question B, but all right, everybody. That's all she wrote today. That's all she wrote. That's actually a TV show, if you're wondering why I said that. There's a TV show called that. There was one a long time ago. That's it. Have a wonderful spring break. We're going to call it good. Keep it real. Keep it fake. Hit that like and subscribe button if you hated this. If you liked it, hit that button. And to tell you the truth, now that I have to switch these to YouTube because that other thing, I'm being facetious when I say hit that button. Don't hit that button. Don't do it. No, don't hit. Don't do it. All right. Peace.